Welcome back. In this lecture we will discuss training algorithms consideration. Welcome back. In this lecture we will discuss training algorithm considerations relevant to deep learning. And so by the end of this module you will be prepared to describe batching and define what an epoch is. And so a popular variant of gradient descent, and as we've seen in other lectures, gradient descent is sort of the workhorse for many machine learning models, everything from deep learning to linear regression to XGBoost to logistic regression and so forth. Stochastic gradient descent is designed to address the issue of, hey, maybe we don't want to go through all of the training data. We can just randomly select one training sample at a time and adjust the gradient that way. And we can maybe get things done a lot quicker. And so here we see this is our typical loss function, and this is kind of the thing that we may want to avoid, because if we have a lot of training data, we're going to do everything in terms of the size of that large corpus. So standard stochastic gradient descent is going to sample just one instance of the training data at each iteration. Now this seems like kind of going in the opposite direction of standard gradient descent that is going through everything. Can we reach a happy medium? And that leads to mini batching. So with mini batching, as opposed to just taking a single sample, we're going to get the derivative based on a subset of samples. And this is what's called a batch size, which tells you how many samples to take, and normally this is set to something like 16 or 32 samples. Full batch refers to using all training samples in a single batch. Now with this idea of batching in mind, we can look at what is called an epoch, and an epoch refers to a single pass through all the data. So if let's say if I have 64 samples in my data set and I have a batch size of 32, after 2 iterations I have completed a full epoch because I've gone through all of the data. Now of course with traditional stochastic gradient descent, an epoch is going to take you n steps, because to get through all of the data, every sample is or every instance is being done on a singleton. And so for mini batch, it's just simply n divided by the batch size. This is the number of epochs is a common measure in terms of training performance, because it tells us how many times the system has to go through the entire training data in order to converge. And a common technique is to shuffle the data between epochs. So the batches that you're picking are in a different order in later epochs as you go on. So this concludes our lecture on training issues. Stay tuned for more content.